How did that go, by the way? This right here. Okay? These are rules that you just have to know. Like if you don't know these, you can't do complicated calculus. All right? And so this is not the first one of these I'm going to give you that derivatives and integrals together. Bless you. You okay? Okay. So just always be on your game. All right? You have to know these all the time. Okay? Look for another one soon. It's going to feel very random for the next week and a half, and I am sorry for that. We're going to take a day and talk about some sigma notation, what it means, how we do it, and some shortcuts. Right now, it feels like it has nothing to do with calculus. Okay? Tomorrow, we're then going to talk about how to find area approximating with lots of rectangles. And then we're going to find area approximations with trapezoids. And that's going to feel random. But next week, we're going to smush it all together, and it will all come full circle along with what we did with integration. Okay? So just trust the process. Even though it feels very random and separated, it will all come together. Okay? And I don't think this is a lesson that you'll really complain about. Okay? Sigma notation. We've seen this before, right? Mm-hmm. Okay? It's the Greek symbol that we use, and it means to do what? Add. All right. So, as a reminder, from what you did back in like Algebra 2 and pre-calculus, right? Did it not? Like I'm pressing this, right? You see this? We're going to try this real quick. All right, time out. We got it. All right. So, in sigma notation, all right, this means sum. We have a lower limit and an upper limit. So it says, hey, start at this number, but stop up here at n. And you're plugging into whatever is inside of your summation. So like this variable should match whatever's in here. That's what you're plugging into. All right, so if that's k equals 1, you start by plugging 1 in for k. And then we go up by integers until we reach our upper limit. So we start off by plugging in this number, the next integer, the next integer, the next integer, until we get to here, okay? So we're going to go through some basic summations, and it's going to feel kind of tedious. So then I'm going to talk to you about some properties that we have with summations and maybe some shortcuts that we can use based on some patterns that we've seen throughout our years of math class, okay? So don't worry about writing this down, okay? Let's talk about the sum, that's what that means, from k equals 1 to 5 of k squared. Like that's how you would read that off to me if I asked you for this problem. Okay? So we start by plugging in 1 into k. So we have 1 squared plus 2 squared, plus 3 squared, plus 4 squared, plus 5 squared. We stop when we plug in 5 because that's our upper limit. That's it. What does that equal? 50? Thank you. What about this? The sum of k equals 3 to 8 of 7. What would that be? Do you see a k? No. So we have 7 plus 7 plus 7 plus 7 plus 7 plus 7. So here's 3, 4, 5, 6, 7, 8. Okay. What do you think? Can we do it? All right, let's do this one together and then the next one's on your own. The sum from k equals 3 to 8 of 2k. The sum from k equals 3 to 8 of 2k. So we have 2 times 3 plus 2 times 4 plus 2 times 5 plus 2 times 6 plus 2 times 7 plus 2 times 8. Yes, it feels tedious. Be patient. We'll work on some things. But let's just remind ourselves what all of this means, okay? You will get to use a calculator, so if you would like to help me out with this, that is fine. What is it? 66? All right, you work on this one together at your table. Okay, notice how this one says I equals 2. Well, look at what's inside of our summation. It's an I inside. So we're plugging 2, and then 3, and then 4 in for I. It is okay to have a different variable as long as you have consistency from here to here. Max, what'd your table get? 49? Are other people getting 49? We have what?
So this Beyonce's got me supercharged right now.
Are you listening to music as I'm talking?
Yeah, it's working out. I swear. I swear, I got 49.
We were not meant to multitask. Okay. Last one. Write it down. Okay, so we're going to work on this one together. When we plug in 1, we have 1 times the sine of 1 pi over 2. What is the sine of pi over 2? Okay, when we plug in 2, we have 2 times the sine of 2 pi over 2. Plus 3 times the sine of 3 pi over 2. Say it louder. So we have negative 2 for ourselves. Okay. Now, I don't know if you necessarily need to write this down, all right? But I want to just bring to your attention that if I were to talk about a summation in general, okay, like let's say like something like this. So we're going to use letters and subscripts. So like B sub k, that's basically describing a sequence. Remember we spent some time on sequences, all right? So we're taking the sum of a sequence, and so then we talk about the first term plus the second term plus the third term, all the way up until the nth term. If that's something you think you need to write down, go for it. But I think that this can just be a reminder that when we talk about the summations, we're talking about the summations of sequences, and sequences are notated like this in terms of their rules and then the terms. Okay. Now there's some properties that I think some of you might assume are true, but I want to make sure that we officially talk about things that we could do with our summations. Okay, and these will eventually relate back to what we can do with integrals. I'll show you how that all comes together next week. But if we have a summation with a constant times our sequence, we can take that constant and it can come outside of the sigma notation, and we can worry about the summation and then multiply it by that constant. Those will be important for our shortcuts here coming up. Okay, these next two you could probably just write together. Like instead of them writing them separate, you could put both of them just with the plus minus sign. But if we have two sequences that are either being added or subtracted inside of our summation, it is perfectly fine to break them apart into the sum or difference of two summations. Okay. You can probably just squish those together and write plus minus, and then you would understand where they're adding or subtracting. So, for example, if we were to have something like this, the sum from k equals 1 to 3 of 2k. This would mean the same thing as if we said 2 times the sum from k equals 1 to 3 of k. those would mean the same thing. I don't think either way is going to be overly difficult for us to do in our head. All right, but 1 plus 2 plus 3 is a little bit quicker than 2 plus 4 plus 6. Okay, so we have 2 times 1 plus 2 plus 3 to get us our sum of 12. Okay. Now where this really is going to be helpful if we have like the sum from 1 to 20, and I'm going to show you some shortcuts for how we can add that quicker than 1 plus 2 plus 3 plus 4. Yada, yada, yada. Okay. We're not going to go all the way through with this one, but just to demonstrate the property that we just talked about, if we had a summation like this, the sum from k equals 1 to 4 of k minus k squared, then we could break this apart into the sum of k equals 1 to 4 of k minus the sum from k equals 1 to 4 of k squared, and then go from there. Okay, those mean the same thing. All right, now I think a lot of you have put this out of your memory, but we did something back in pre-calculus called proof by induction, okay, where we took the sum of a sequence and we proved a shortcut. Okay, the reason why I think you forgot is I had it on the board one day and some of you are like, I don't know what that is, okay, and that's fine. We did it for a couple days and we moved on. But the shortcuts that I'm about to show you are shortcuts that you proved last year if you had either me or Miss Cronky for pre-calculus, okay? So I want you to write these down. You are going to use these. You are going to need to remember them, okay? So our first shortcut, if we have the sum from k equals 1 to n of k, so 1 plus 2 plus 3 plus 4 all the way to n, it is the same thing as this right here, n times n plus 1 over 2. Okay, so if you have the sum from 1 to anything of k, instead of actually adding everything together, we can use this shortcut right here. Okay? Takes a lot less time, especially the bigger the number of for your upper limit. Okay, if you have the sum from 1 to n of k squared, instead of doing 1 squared plus 2 squared plus 3 squared, yada, 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 this is our shortcut. And one more shortcut. I'm hoping that you see a little bit of a pattern here. If we have the sum from 1 to n of k cubed, instead of taking 1 cubed plus 2 cubed plus 3 cubed, etc., we can take n times n plus 1 over 2, the quantity squared. Does this right here, n times n plus 1 over 2, look familiar? Okay, that's your shortcut you wrote for k. So your shortcut for k cubed is that same thing for squared. These are shortcuts that I'm going to ask you to know so that we can do our summations quicker without having to rely on the capabilities of our calculator. The reason I need you to be able to do this is so that when we get into how to use these to understand integrals, we're going to be doing these, but they're not always going to involve numbers, okay? So I need you to be able to understand how to get from there to there. So we'll go slow. The summation from k equals 1 to 23 of k. Well, our shortcut is n times n plus 1 over 2. What would our n equal in this scenario? 23. So we have n times n plus 1 over 2. (23 times 12 would be) Now let's do a k squared. The sum from k equals 1 to 7 of k squared. Since our upper limit is 7, and we started at 1, we can take n times n plus 1 times 2n plus 1 all over 6. So n times n plus 1 times 2n plus 1 all over 6. So, let's see. Huh? 140? Yeah. I was getting there, but slowly in my head. Okay. All right, let's try a cubed 1. Model. I do each of these for you. Okay, so k equals 1 to 6 of k cubed. For our k cubed shortcut, we are going to take n times n plus 1 over 2, but then we're going to have to take that quantity squared. So it looks similar, or it's the same fraction as you have in the k shortcut, but then we just have to square it. All right, so help me out. What is that?
441.
Now, I'm not going to give you very many of these, just boom, straightforward ones. Okay, we're also going to have to be able to work with these when we have more than just k squared, or k cubed in our summation notation. So what if we had something like this? Here we have the sum from k equals 1 to 30 of k times the quantity k plus 1. What would we need to do in order to be able to use our shortcuts and not have to add the first term plus the second term plus the third term, etc.? So we can only take a constant and put it out in front, but since they're being multiplied, what can we do? we can actually do the multiplication. This would be k squared plus k. And what can we do if we have two terms added together? I know that there's a shortcut.
I was just.
I know. So we would have k equals 1 to 30 of k squared plus k equals 1 to 30 of k. That's k. So we can distribute and then break it up into multiple summations. Okay. So since we have a k squared summation, we would have to take n times n plus 1 times 2n plus 1 all over 6. And then over here, we would take n times n plus 1 all over 2. Like I said, I know that your calculator, you can like type everything in and you don't technically use the shortcuts because your calculator's smart enough to do it. But we do need the shortcuts for when we don't have 30 at the top. We have like n up there instead. What do we get for this?
485.
What?
485.
I don't know.
I don't know. I probably did something.
Well, you should always have integers because we're adding integer values
Yeah.
together.
Yeah. I don't.
Well, look at what you typed in. Did you type in something silly?
Oh yeah. Yeah, I did something.
9,000.
Okay.
Yeah, thanks.
Okay. Okay. I know that this isn't like showy or really that exciting, but it's at least a nice, simple lesson to get us back in after our long weekend, right? Okay. I would not. I don't know if you have to write this down, but you're gonna see the book ask you to write something in closed form. So when they ask you for closed form, they mean, hey, use the shortcut, versus like open form would be like the 1 squared plus 2 squared plus 3 squared, etc. Open because we don't actually know how many terms are in there. Closed, we could actually just plug something in and be able to get our outcome. Okay, so I have one last example for us where I'm going to give you a summation, and this is why we're going to have to know our shortcuts. Our summation has an end value of n, and I'm going to ask us to write it in closed form. So I'm going to ask us to use the shortcuts to write it so that we could plug something in if we had it. Okay. So our last example, and then I'll talk to a couple of you juniors with the remaining time. So go ahead and write that down. Notice how we're starting at k equals 1, but then we're going to n. Before we can use any of our shortcuts, what are we going to have to do? Okay, we're going to have to distribute. So we know that 3 plus k, the quantity squared, is 9 plus 6k plus k squared. Do you agree with that? Okay. So then what we're going to want to do is we're going to want to break this up into 3 summations. The first summation for the first term, 9. Then I would write 6 times the summation of k. This is when we would move that constant outside of the summation to use the shortcut here, plus our summation for k squared. Now we haven't really talked about what happens when we have just an integer. How many, like what are we doing here? We're adding 9 plus 9 plus 9 how many times? Repeated addition is the same thing as multiplication. Okay. Plus, we have 6 times our summation for k. Well, that summation is n times n plus 1 over 2. Then we have our summation for k squared. Okay, well, that shortcut is n times n plus 1 times 2n plus 1 over 6. Here, your calculator is no good. You have to know the shortcuts. All right, so your homework, what I want you to look for, it's the 4.2 homework after the quiz. The dates are going to be all messed up. Okay? We had to add in a day because of the ACT diagnostic. Then we had a snow day. So just, I would maybe like start checking things off. All right? So the last thing we did was take a quiz. So it says 4.2, and I have it labeled it wrong. It's definitely not area. But it's the first 4.2 homework. Okay? It's the first 4.2